Hi. All right, you're looking at a balancing worksheet. Maybe you watched a video on balancing, maybe you didn't. I'll give you the quick rundown. We're going to try a few of these for problems, and then you'll have some of them to do as problems as well. But let's get into balancing and just pick some of these to kind of pick and choose which ones we want to balance, and maybe just go through some kind of pointers. Balancing, first you should know, is you can always check your answer, which is nice about balancing. So as you go through and balance, it'll always be very obvious to you if you're doing it right or if you're doing it wrong. Secondly, probably use a pencil. It's kind of an art form, but it's also sort of trial and error, so you might mess up and you want to definitely check. You'll be erasing a lot, so that's a good thing to know. To have a pencil will be a much better tool than a pen, probably. Okay, we'll start with easy and maybe work our way up to some that are not so easy, and I'll give you some tips that will hopefully help you along the way. First of all, when you're balancing, you can start anywhere and you can finish anywhere, and all you can do is put numbers in these places here. That's it, okay? Each number you put in front distributes. If you watch the video, you know this already. So if I put a 3 here, that distributes to everything. And remember that these numbers only apply to the things that they're directly behind. So that's, if I was no numbers there, that would be 3 hydrogens right here and 4 oxygens right there. Okay, but if I put a, 3 out in front of it, that would be 6 hydrogens, and it would be 3 phosphoruses, and it would be 12 oxygens. Okay, so that's just one thing to keep in mind when you're doing it. Now, again, you can start or you can finish anywhere you like, and a lot of it is just experience, okay? So I think when I look at this one, one weird thing, and again, this is just me, but you can start anywhere and you'll just find yourself bouncing back and forth. But for me, I noticed that there's 5 chlorines there, and there's only 1 chlorine here, so I'm gonna put a 5, okay? When I do that, that gives me 8 hydrogens, right? I got the 5 hydrogens right here, but I also got 3 hydrogens right there, so all of it counts. You're trying to make each side equal. So 8 hydrogens, I could put a 4 right here, and that would give me 8 hydrogens. And then let's see, now I can check where I'm at. So let me erase some of this stuff so you can see what's going on. So let's check what I just did. When I put a number here, that distributes to everything. So yeah, I fixed the hydrogens and I've got 8 on both sides, but now I only have 4 oxygens on this side, on the right side. Oh, and I got 4 oxygens on the left side, that's good. And let's see, we already did chlorine. So phosphorus, 1 phosphorus right there, 1 phosphorus right there, and guess what? I'm done. Everything is equal. We got them all equal. A little bit of a weird one to start with, but a good one in that we saw you're kind of bouncing back and forth a little bit when you do them. Let's see if we could find one more representative of what kinds of things you would do when you're doing this. Might as well just get into, let's say, let's do number 2. Okay. So when you're doing this, again, you can start anywhere. It's best, one thing that you can do to make it a little bit easier for you is that if this says NO3 here and that says NO3 there, it's better to think about them as like 3 NO3s on this side and 1 NO3 on that side. You can group them together if they stay together, makes your life a lot easier. So that's one thing. They do the same thing with the carbonate is here as well. 1 carbonate there, and you've got 3 carbonates there. This 3 right there means you've got 3 of the carbonates. So that's one trick that you can use to keep them sort of together if it works for the particular thing you're balancing. But for me, when I'm looking at this right off the bat, again, start anywhere you want, but I notice that I've got 1 aluminum here and I've only got 2, I got 2 aluminums there, so I'm gonna go ahead and put a 2 in front, okay? That 2 distributes, but instead of saying I'm just gonna distribute to each of these elements individually, I'm just gonna say, oh, it's because it's grouped together, why not just treat this as one thing, right? And then we're saying it's got 2 times 3, or 6 NO3s. So I'm gonna go back to the other side and make this 6 NO3s, which is right there, 6 NO3s. However, when I do that, again, every time you put in front messes something else up. So now I've got also 6 sodiums, so I bounce back to the other side. I have 2 sodiums, I want it to be 6, so I put a 3 in front of it. 3 times 2 is 6, okay, perfect. But that also distributes to the carbonate, and guess what? I've got 1 carbonate here, but 1 times 3 is 3, and on the right side, hey, I already have 3. So this one is done also, and on all of these, I always like make a bunch of notes like to show you what it is that I'm doing, but you don't obviously need to have any of that when you're doing it, you just need to have the answers, which are on the lines right there. Oh, there's still even more arrows to erase. It's bananas. Okay, so that's another example where we have some that are you kind of group together and make your life a little bit easier. But each one's like a puzzle, okay? It might take you a second. It might take you 5 minutes. You just trial and error until you figure it out. Okay, that's what is good, but also frustrating about them. So no easy way to say that about them. All right, let's take a look at maybe a number 1 and try that one. And then maybe that will be it for these. Although we could do some more, I guess. We can do some other ones, some more easier ones. Let's look at number 1. In number 1, we've got, well, okay, here's another tip. If it's something that's by itself, just leave it for last because same thing here. If you can, leave it for last because it's alone. You could put any number you wanted in front of those and it wouldn't mess anything else up. Like if it ends up this being a 7 or something, that's cool because at the end, any number can go in front of it. So that's another tip that might make your life a little bit easier, but there's really not a lot of places to start here. Let's see, because aluminum is set. Aluminum, potassium, oxygen. Okay, so you could do oxygen, but there's 3 on this side, 3 oxygens here, but there's only 1 on this side. I know that gets kind of messy, so I'm going to avoid the 3 and the 2 for right now. And let's try to start at, I mean, you could start there. It might work too. I'm not saying that that's the wrong way to go. You certainly could. Let's see. I'm going to start at I kind of have the same situation with hydrogen. I have the 3 of them. So sometimes in a problem like this, I'm just going to take a shot and I'm just going to double to get an even number. So like I said that I've got the 2 hydrogen here. Oh, and I already have 2 there. I think I said 1 before and I was mistaken. So I can't even start there. I have to start on hydrogen. So let's start on hydrogen. I've got 3 on this side. 1, 2, 3. And I only have 2 on that side. So sometimes when you have a 3 and a 2, it's best to get them to a common multiple, which would be 6. And so what I'm going to do is to make that happen is I'm going to put a 3 here to get that to be 6. And I'm going to do a 2 here and a 2 there to get them both to 6. This is not a great example because I'm taking a lot of guesses and I'm hoping it's going to work out. Okay, so then I've got the 2 potassiums here, so put 2 potassiums there, 2 aluminums there, 2 aluminums there, 6 hydrogens again. I got the 2 hydrogens right here. I've got the 4 hydrogens there is 6. 3 times 2 is 6. And then for oxygens, that's the last one. I was kind of hoping that would all work out. I left till last, even though I said leave aluminum for last. I didn't. So 2 oxygens right there, 2 more right here. That's 4. And guess what? 2 times 2 is 4 as well. So I took some guesses. It paid off. You know, anytime you're getting numbers that are like in the double digits, maybe you're bouncing back and forth a lot, you probably can just nuke that one and start over again. Okay, so that's why again a pencil's a great idea because I took some swings there that worked out, but again I was guessing on a lot of them. So, but that's exactly how it goes sometimes. Let's try one more maybe that is more straightforward. Maybe like a something like number 7. Is probably a little bit more straightforward. When you're looking at number 7, I mean, you might as well just start with the phosphoruses because it's right there, right? So 4 phosphoruses on the left-hand side. So I'm going to put 4 there. And that 4 distributes to everything. So that would be 12 hydrogens. 4 times 3 is 12 hydrogens. So I'm going to bounce back over here and put 6 for the hydrogens because 6 times 2 is 12, okay? But then it also gives me now, on the left-hand side, I've got these 6 oxygens plus these 6 oxygens. That's 12 oxygens. Guess what? 4 times 3 is also 12 oxygens. So there you go. I did it. And all I did was kind of bounce back and forth to make it happen a lot easier. I bet you wish that I would have picked that one instead of number 1 to do previous. But that's just the way it goes sometimes, and you're going to have to live with it. Ooh, one more tip we can do is number 8. Sometimes when you have OH and an H on one side and you have water on the other side, sometimes writing that water is a little bit easier if you write it as HOH. Ooh, let's color code it for the MEMS. Okay, so that's the same formula, HOH is H2O, but that OH is the purple OH, which is this one, purple OH, okay? And then the pink H is the one on that side by itself. Then you can kind of treat them differently, and it makes balancing a little bit easier. If you don't like that, you certainly can do it the other way. Oh, this should be a small number. Sorry. That's terrible. This is terrible. Leadership from me. Anyway, so start anywhere you want, but I'm just going to go with aluminum because there's 2 of them here, but there's only 1 in the mirror, so I put a 2. That gives me 2 times 6 or, 2 times 3 or 6 purple OHs. So I'd put a 6 out front. Oh, pink is not a good color anymore, is it? Let's go with blue. So that's a 2 there. That gives me 6 purple OHs, so I put a 6 there, 6 purple OHs, but also gives me 6 pink H's, so I put a 3 on this side because 3 times 2 is 6 H's. And again, treat this as one thing, makes your life a little bit easier. Do you see how I've got 3 SO4s here, and I already have 3 SO4s right there? And do you know what that means? It means we're done. So now I can get rid of all the extra things I wrote to help show you what was going on, but that is the balanced equation. You can write that 6 below if you want to, like this. Okay. Any blank line that I've left is a 1, but you don't need to write the 1s when you're doing balancing. Okay, so there's a bunch, some of them more complicated than others, of balancing problems. Try as many as you can, and actually there probably is a number you're going to try, and it'll be on Schoology, so try that number and have that number done, and submit it to Schoology when you're done. And this has been so fun. We'll see you. Bye.